name's Heidi Pichet-Dempsey, and this is Mike Patton, and we're here to talk a little bit about the GENI project, which is the Global Environment for Network Innovation. This is a new project that has been started by the National Science Foundation, and we're really interested in getting input and suggestions and hopefully active experimentation from operations and network engineering folks. So we're here to try and talk about what we can do on this network and hopefully get you guys excited about things that you can do. Mike and I have been building prototype networks for several years, probably over 20 years each. And so some of you may have met us previously in incarnations working for ISPs or peering for some research networks. And if not, you're going to see us again soon. So, I'd like to talk a little bit about what GENI is, and then how we think that researchers and ordinary users are going to use it in the next few years. Whether there's any ways that the GENI project can benefit the NANOG community, and the answer to the last question of whether operators can benefit GENI or not, we already believe the answer is yes. But of course, I'm going to ask you for some specific things that you could do to help us out. So the GENI project got started at an NSF workshop that was sponsored in 2005. And at this workshop, a bunch of industry and academic research people got together to try and think about what would the internet look like in 20 years. And what were the likely changes that were going to be needed in the infrastructure, in the protocols, and what were the changes that were going to happen just in the user base over that time period. And of course, nobody can really predict what it's going to be like 20 years from now, right? We can make a pretty good guess here, but we're probably wrong. 20 years ago, when Mike and I started doing this, there were no routers. I worked on the first team that deployed hardware from BBN to build a router. So it's really a long time, and it's hard to think about how many things can change over that time period. So most of the stuff that you take for granted every day when you're working on network engineering, suddenly you have to think more about when you make your time scale longer like that. So what happened at this workshop was that the folks who were there pretty much agreed that things were going to change extremely dramatically because of changes that were coming in optical fiber switching and the ease and the speed with which we could change the optical substrate. Changes that were coming in the proliferation of endpoints of the networks, the idea that there's going to be lots of sensors and sensors could be addressable, and rather than a small core and a lot of end users to a network, there are going to be a huge number of possible end users with all sorts of different substrates and all different ways of connecting. And then the idea that probably distributed computing was going to be changing a lot. And so the ways that you could combine different things and the ways that you could share resources were going to be a lot more dynamic and a lot more changeable. So if you think that this many things are going to change about the network, then it's pretty exciting, but it's pretty scary if you think about how you're going to get those things into an infrastructure that's already out there and deployed. And as our last speaker mentioned, theoretically we have pieces of the network now, well, not theoretically, actually, that are doing 9/9s. And it wasn't so many years ago that people were laughing about the idea of the internet ever being able to do 9/9s availability. So NANOG people have done an excellent job at making it really hard to deploy new stuff, radical stuff onto the internet. So we want to have a place where it's a little easier to do that, and where it's easier to look into the things that you might break and actually break them and recover and change protocols and those sorts of things in a research infrastructure. So the statement for what GENI is trying to do is to build an infrastructure where we can explore those radical designs. And being a system engineer, we like to break those things down into what those words actually mean in terms of requirements. So the national facility means it needs to have a wide area footprint. It really needs to be available all over the US. It needs to allow the experiments to be large with the same kind of geographic reach, but also with really large reach in terms of the number of people who can participate in an experiment, and the number of experiments that can run simultaneously. So we're looking at being able to run 1,000 different experiments simultaneously, and all of those experiments being potentially scalable up to hundreds of thousands of users per experiment. The other thing that you need to do if you're going to run that many experiments in an infrastructure that's shared is figure out how to make sure they don't all stomp on each other. So we need to be able to use slicing and virtual computing in a way that lets people get access to their resources and maybe mess up their slice of the network but not impact everybody else. So if we build that network, what are we going to do with it? Well, first of all, we're not going to build it from scratch. There's a lot of pieces that are around already, and the GENI project recently did a solicitation asking for people to propose what things they would bring to the network and what kind of research they'd like to do. And we got quite a few people responding to that, and we're expecting to make awards soon. So we're not going to have 1,000 experiments in the first year, but we're going to have certainly somewhere could go up to 100. And we're going to be exploring that and starting to show up in people's network tables in the next 6 to 12 months. So it's very important for the kind of research that we're trying to do that people can run in an infrastructure that has real traffic and really complex routing that's based on the real world coming into our network. So that's the kind of exploration that's going to go on. We're also planning to do this in an open environment, so the source code that people use will be made available. And there are a couple of IP policies so that industry people can participate as well and make their hardware, software applications available to the project. The final part of what's required is, like I said, we're exploring the future. And so that means that we need to support networks that don't use IP. Now, I know that proposing that networks don't use IP doesn't mean I'm standing up here trying to bring back ATM, so don't spam me. But we're trying to let people have the flexibility to come up with new protocols. Some people are interested in doing routing based on content rather than routing based on connections between computers. Some people are interested in doing routing that's much more flexible and responds to mobile networks and endpoints moving around better. And some people are really interested in the optical research and making the core of the network more easily changeable in response to changing demands. So we're expecting to look into all those things. We're expecting the GENI infrastructure will include storage. It will include new kinds of hardware nodes. We can't call them switches. We can't call them routers because there's something in between. And that all of the components on this shared substrate are pieces that a researcher can download code into. So if you get access to the GENI network, you're going to be able to actually run your protocol on your piece of the network and see what happens, not just get a certain bandwidth through the network with a certain number of endpoints. And then the last two things under the future infrastructure that we know are problems, but we don't really have a lot of active proposals yet, is how to build in security and privacy protection from the beginning. So unlike the way the IP protocol began and developed, where most of that stuff was added on later, we want to try and get it in there at the beginning. And we also want to involve end users in the research. So people who are going to be able to go to research websites and download a GENI client in order to participate in a project. Think kind of like SETI at home, only maybe a little bit more interactive and doing a little more network things to participate.
People on their networks.
I'm sorry?
People on their networks.
Yeah, people in your networks, Mike says. So people who are participating in the research may well be your customers, they may well be your customers' customers, and you should start seeing their traffic. So how are we going to build this? Obviously, you can't build something to last 20 years in one shot. So we're expecting to be prototyping and building out the test infrastructure. Like I said, the meeting where the idea came up happened about 3 years ago, and we're expecting about 3 years of building and doing cycles of deployment and integration. So the first one we expect to start showing up in 6 to 12 months, and then there'll be kind of roughly 6 months iterations after that for new versions. And I remember sitting in these kind of conferences and listening to research proposers and saying, well, you know, that's nice, but who cares? I don't have time to worry about that. And I'm sure most of you are probably thinking the same thing. And so what I'm trying to make as a point here is that, you know, sooner or later, you're going to call us in the middle of the night. Hopefully not sooner, but we're trying to, you know, proactively make it so that that is less likely to happen, and hopefully give you something that you can get out of the network in the meantime. So please do feel free to stop Mike or me or send us email. All the contact stuff and all the details for how this is going to happen are on the GENI website. And this is just a really brief overview of that. As far as how this whole thing is organized, the NSF is the sponsor, and they provide the funding, which is, this is a multi-year project with a budget in the tens of millions. The yearly allocation, of course, it being a government project, goes through review every year, but it's expected to be a multi-year project. And so the NSF sponsors 2 different groups. One, the Network Science and Engineering Council, who are supposed to represent what network researchers really want and what network engineers really want out of future infrastructures. And then the GENI Project Office, which is where Mike and I are, which is tasked with actually building the infrastructure, doing the prototypes, getting the whole thing working. So how do we think this is going to look over time to an end user? So you've probably figured out by now that researchers are really our customers. And the way that we envision researchers interacting with the GENI project, like I said, they're going to be able to download their own code. They're going to be able to reserve slices of substrate, slices of processors, and slices of different kinds of infrastructures like wireless. And so we envision that there's a central clearinghouse that lets that happen through programmable APIs, and that uses digital authentication and verification so that we can keep track of who those researchers are, who they want to be able to join their projects, and for the upcoming research period, what kinds of resources they've asked for and been granted in the network. So at first, that's fairly easy to do because we own the initial parts of the substrate and the infrastructure ourselves, and that's what the bluish clouds here are trying to show. And the researcher's slice goes through that. And so it should be fairly easy to make sure that when we say that somebody can have access to a wireless network at a certain time, that's going to happen, modulo the things that are always unsure in a network. But we expect that over time, some of the industrial partners are going to be donating facilities. So those won't be owned by us or controlled by us. And also, we know that there are some similar projects going on in other countries. In Japan, there's a project that's very similar to GENI. And in Europe, there are several different projects that are similar to GENI. And they're all building research testbed infrastructures. And we're talking about essentially how to peer with them for an experimental infrastructure and how we would go through those kind of agreements and settlements. So from a researcher's point of view, we want to make it look really simple, but from the back-end point of view, we're expecting clearinghouses and ways of sharing data between these different organizations so that we can take out clouds, put in clouds, and have the whole thing change technologies without the whole infrastructure trying to go down. The previous speaker mentioned something that we're all familiar with, which is outage windows. And you like to have a planned outage window, but once you start doing a network that involves 20 different providers in order to run an experiment, you quickly find that there isn't really a single outage window that you can talk about. So coordinating gets to be pretty complicated. So this is trying to illustrate how the GENI network looks to the researcher end user and how it looks to the participant on the general internet who's trying to opt into the experiment. And there are a lot of slides that show simpler versions of this on the website, but I just wanted to show this one to kind of get across a couple of ideas. The boxes across the bottom are aggregates. So an aggregate is basically a group that owns a set of resources and manages them. So somebody who owns the backbone will provide backbone bandwidth and switches and different kinds of optical interfaces to grant a certain amount of bandwidth to this researcher, who may also download her code to those nodes. Another aggregate for this experiment here will provide some wireless, and a third aggregate will provide some compute resources out of a couple of compute clusters that will be sitting on GENI. And so up at the top, you see that the researcher talks to the clearinghouse in order to make the yellow boxes that happen around those three aggregates happen. So basically, the yellow boxes symbolize that there's been an agreement between the aggregates and the GENI clearinghouse about how to provide what the researcher needs. Now, if the researcher's experiment is really successful over time, she's going to want to grow it. She's going to want to change pieces of it. And this shows an example of when she's saying, change my slice. And a slice is what we call the piece that cuts across all of those different aggregates. And in this case, she's trying to add more resources that are owned by one of our commercial partners, and they happen to run their own clearinghouse. And the reason to run your own clearinghouse is basically because you want to have some policy control over the resources you're providing. So there's a negotiation between the two GENI clearinghouses, between the commercial clearinghouse and the GENI clearinghouse on her behalf, and the new resources in aggregate D are added to her experiment. At the same time, anytime during this, people who are on the internet connected to GENI in any way or tunneled through the internet to get to a GENI access point can say they want to join the experiment. And so that also happens through a clearinghouse, although not in as direct a way as the researcher's path. So, for example, what one of the projects we're working with has proposed is that there's a website you go to and you can download the GENI client. The GENI client will go and tunnel to the nearest GENI access point for you and basically ask the user whether the user wants to use the GENI resource or not, so that they are informed that they're now part of an experiment and not on the normal internet. So the important thing about all of this is that unlike a normal research project where you can pretty much control everything, in this research project, the idea is to make different groups cooperate and to make a more flexible infrastructure where you can change things more quickly without having the whole thing be out of control and difficult to debug. Kind of a big challenge. So what do you do when you work in operations like we do? You figure out what are the details that you go through to make this happen. So again, on the website, we've got some detailed operations procedures that are posted, and we very much like to get people's comments on these views. Mostly from this audience especially, we'd like to know whether it's at all realistic to expect that two different organizations that own different aggregate resources would ever talk in the way that we imagine here. Now, I know they wouldn't this year, but the question is, could they ever over the next 12 months or the 12 months after that? So don't worry, I'm not going to read through the details of this slide, but I'm just going to talk about a couple of highlights I think that are interesting. So the first thing that happens on this slide, the drawing of all the ovals shows the different aggregates that are part of this particular experiment that's going on. And the aggregate operations on the CPU cluster notices that there's a problem with their equipment in the CPU cluster and decides that they need to shut down the piece of the experiment that's running on their piece of the infrastructure. And so they go ahead and do that, but they can't just do that. They need to be able to tell GENI operations about it as well, so that the other slivers that are running in other infrastructures know that this piece has disappeared and can do something about it if they need to. So one of the interesting questions that comes up from this is, what does it really mean to be broken in this kind of an infrastructure? Because maybe I don't care in my aggregate that the compute cluster has gone down. If I'm providing access across the backbone, I probably don't care that the traffic may have dropped some because some of the compute cluster pieces have disappeared. So it might mean nothing to me, and I might think it's not broken at all. On the other hand, if I'm perhaps running a processing center that's sharing with the compute cluster the job of what this experiment is trying to do, then I'm going to care a lot, and I'm going to want to know in detail exactly what pieces of the experiment are broken and how. On the other hand, the experimenter could possibly be breaking things on purpose, right? If you're deploying a new protocol, one of the things you want to test is how does it respond to outages, how does it address different things disappearing. And so in this example, that obviously isn't happening because the aggregate operations noticed the problem. But in the general case, it could be that something that's interpreted as an outage by operations, either in GENI or in an aggregate, isn't really an outage at all, but it's something that the experimenter is doing on purpose. So you don't want to have all of the details of every experiment exposed, but you do want to be able to tell the difference between something that's seriously wrong and something that's probably okay. Is that squishy enough for trying to write? Yeah, trying to write an operations procedure around. The other thing that's interesting here is, and another thing we'd really like your feedback on, is how much of these communications can be automated back and forth. I know that the last time I was operating in an ISP environment, most all of our information needed to be kept proprietary, and you couldn't give access to anyone directly who you worked with in operations for most of the information. And we had just started to try and get some shared databases, of kind of sanitized data out there, but it hadn't made a whole lot of progress, and it certainly hadn't become a dynamic thing that could be changed on a minute-by-minute basis very easily. So I'm interested to find out whether things are better now, whether you think there's any hope of that ever happening, and what would have to be true about any kind of shared database or other shared infrastructure in order for you to be able to put that kind of data out there. So now to the most important slide, what can GENI do for operators? Maybe nothing, I hope not. Please come up and object if you think the answer is nothing. But one of the things we're obviously going to be working on, because we have to connect to real traffic and real networks, is how to do network exchanges, particularly between networks that don't speak IP and networks that do. But also how to do exchanges from different kinds of aggregates who might all be speaking the same protocol, but have a different goal than just connectivity or just a delay measurement. So what are the technologies for that kind of thing? There's also hardware development that's going on, so some of those things that aren't routers and things that aren't switches will be showing up in the GENI network, and if you're interested in ways that those could be used for processing exchange information, that would be another way that the GENI project might be interesting to you. A second way is, like I was mentioning on the previous slide, how operations and management can span organizations. What kind of security and what kind of privacy controls do we need, and what kind of technology do we need to make it easy for that to happen? Another suggestion, because GENI is an experimental infrastructure, we make slices of the infrastructure available for experiments, not only for people from academia, but also for industry. So if you have a need for testing some kind of a backup recovery or disaster recovery situation where you need large amounts of bandwidth, you want to try putting your data on an infrastructure that doesn't belong to you and see how it works. I know from doing these myself that it's hard to sell management on going off and buying some resources just for the purposes of testing out a disaster recovery scenario. Whereas with a network like GENI, A, you don't have to buy it, and B, the resources can be there for the time when you want to test and then go away, so it's not a long-term investment with a lot of capital tied up in it. So maybe there are things there that would be useful for you. For the GENI network, it would be very useful because it would provide a lot of traffic going across that would make the network more realistic. Another example, obviously, is how to provide services across providers. So the name of the game in operations and integration is always defining your demarcation and the piece of the network that you're responsible for. But the name of the game from the end user's point of view is always the application has to work end to end. And so those comments about my internet is broken, can mean something simple like my application won't boot, or I'm talking to the mouse. In a network like GENI, we're expecting to actually try and make an experiment, which is an example of an inter-provider service, work and be delivered that way. I mentioned before at the beginning that we wanted to involve real end users. So if you have ideas about how we could do end user services or tools we could put on end user machines, or clients that would be interesting to run on end user machines, we probably have a pool of GENI end users, particularly when we start having normal people opting into the network. Normal. We might have a way to deploy those kind of ideas. And last but not least, the GENI network is going to have slices that are specifically there for testing operations and testing operator tools. And so if you want a different kind of environment to test a tool that you've written, or if you want to get a different kind of data set on the tool that you think is already working, the GENI network is a good place to try that out. So those are the things we could think of. If you can think of more, please tell us. What we'd like you to do for us, if you walk away from here and only do one thing, I would like it to be signing up for the working group that does operations on GENI. And that's the first one listed here. All the working groups are on the website, and the first one is called OMIS for short. It actually has integration in its name too, even though this slide doesn't say integration. And one of the problems that we really have, because the whole idea started in academia, is not enough people participating from operations and emphasizing how you need to design operations in from the start, and taking some of the challenges that you guys see every day in operating networks and trying to come up with solutions for them. And we'd really like to fix that and get more active participation on the mailing list. Yeah, it's a low traffic mailing list, Mike reminds me to say, because I know lots of you are subscribed to hundreds of mailing lists. So, and we're perfectly happy to have people who just lurk or who just make comments and never show up, because that will help us even if you participate at a low level. And if nothing else, it'll give you access when you want to complain about us in the middle of the night. The other working groups that we have are substrate oriented. So if you have a particular technology that you're interested in, wireless, distributed computing, optical, substrate mailing list is, would love to have your input. The control framework is the mailing list and the working group that thinks about what's the minimum set of software and APIs that you would need to support if you were building one of these GENI nodes or a piece of GENI infrastructure. What's the smallest, easiest thing that we can require people to do in order to do those transactions I was talking about, which have to do with recognizing an experiment and giving access to that experiment for the right time to the right resources, and doing the slicing and isolation in such a way that that experiment can go on without impacting other experiments if it misbehaves. The experiment workflow working group is basically about writing tools that make it easier for researchers to do experiments. So there's plenty of researcher people there already, but if you have ideas for the kinds of experiment tools you'd like to see, that's a good one to be in. And user opt-in is the final one that tries to figure out motivations and software and structures that would help to make GENI interesting to regular internet users so that we get a lot of them involved in our testing. So I'd really hope that you would participate in these. We also do meet in person every few months. The next meeting is going to be this fall, and information about those meetings is on the website as well. So that concludes the brief summary. If there are any questions, please step up.
Brian Dixon, a couple of quick questions. In terms of geographic/political scope, is it limited to participation by U.S. entities?
So there's two different sides to that question. One is, will you be funded by the NSF? The NSF does actually allow funding of partnerships that involve people outside the U.S. Of course, it's a harder case to make, but it is possible. But as far as participation, they're 100% in favor of that. And they've been actively planning to, like I mentioned, these research networks in Japan and Europe. People from the NSF themselves, as well as GENI people, have been going there trying to work out how those connections will happen. So participation definitely, and funding a little harder.
How about Canada?
Oh, Canada, yes. We've been, sorry, Canada. We've actually been up to Canada to talk to some of the research programs up there, and I should have mentioned it, I'm sorry. In particular, the Green Networking project that's pretty active about data centers and how to make them have a zero carbon impact. But yeah, definitely Canada and Mexico, although none of us have been to Mexico yet. But
Another question about, what about element interoperability stuff? Is there going to be, is that in scope, out of scope, doing testing on that and publishing results? Because I think that's something that could be of interest as well.
Yes, definitely. We expect actually during the first couple of years that different people are going to be developing different elements that will be in competition, and that testing between those elements and also to outside exchanges will be probably a pretty hot topic. But it takes a while for the hardware pieces to get developed, so that's probably why 2 years.
And is there going to be any in GENI work being done in terms of analysis, measurement tools, that kind of stuff? Or are they strictly supporting other people doing things?
That's a good question. I should have actually emphasized that because it's a research network, the measurement tools and the analysis tools are really important. And the researcher support working group that I mentioned is definitely focused on that. And we have a architecture for a GENI measurement system, which is kind of a whole different data/control plane through the network. That's there specifically to collect more detailed measurements. But we don't have a lot of proposals yet for what should sit on that plane. So we're actively interested in soliciting for that kind of thing. But thanks.
Sandy Murphy, Sparta. I have two questions. Previous gentleman asked three, so I think I'm allowed.
There doesn't seem to be competition, so.
Will you have production-level routers as first-level resources in the network? Like people could allocate or those to their experiments?
Yes, we will. And maybe I'll let Mike answer that question because it's a little painful. Because they won't be everywhere. And the definition of production level is hard. So do you want to try and take a cut at it?
Well, the question of what will we have in the network is actually a very hard one, no matter which thing you're asking about, because of the 20-year lifespan. What we're going to have in the network in the next 10 years is not what we're going to have in 20 years.
Mm-hmm.
But in the plans that we're thinking about, we have, places where we want to have standard off-the-shelf type routers because we want to look like existing running IP networks, and there are many other places that we want to have something else because we have the demand for having the sliceable the sliceable and programmable capabilities, which commercial off-the-shelf routers don't have. If they had it, we could buy them, but they don't have it, so we would have to do something more elaborate. And it's a complex balancing act of where do we want some components and where do we want others. For example, at an IXP, where we have one tail circuit that comes into the IXP to exchange with all the other ISPs out there, since they're not going to be speaking any of the strange protocols that are inside GENI, that would probably be could be just a regular commercial router. But inside GENI, where we have to do the slicing and multiple experiments, those would probably not be.
But certainly if you had more interest in, more of those things being around, it would be good to hear about that.
I was just wondering about the possibility, you were talking about different routing protocols and combining new routing protocols and old routing protocols and seeing how they interact,
Right.
or doing a faithful one-to-one network simulation
Mhm.
for an ISP or whatever.
Yeah.
Okay.
Yep.
I have this really strange diagram that I made up once that shows basically, when you start thinking about the slicing capability, you realize that GENI could be, each slice is a national ISP, and they're going to peer with one another, and they're going to peer with other things, and the actual picture gets to be very, very messy. But we're, as operations people, knowing how the rest of the world operates their networks, we're trying to make it so that all of that mess is completely inside GENI, and we'll have one BGP session with someone else, and they don't have to care about what the details are inside GENI.
My second question is sort of security related. I noticed your federation of sites all over the place, including international, which is scary. Making a rough analogy to independent federated cooperating ASs and the problems that we've had of mistakes in one AS announcing prefixes that belong to somebody else and inability to correct that problem, only react to it in other sites. And I was thinking about Purdue experiment is running on an Indiana University site around the time of the old Oak and Bucket game, and the undergrad hotshot is taking advantage of his access to the network to do something entertaining to the Purdue experiment from the IU campus. How are you going, if you come up with a way to prevent local physical access to a device, to keep that access from allowing you to make changes to something that is running locally, that might be a benefit to the networking world. But if you have ideas of how to do that, that would be entertaining to hear about.
I haven't heard anybody propose yet any idea how to, I mean, basically it sounds like sort of you're saying, how would you verify that a change that happened locally, say through a terminal interface directly, was really authorized? So beyond kind of the standard, you know, assuming that the person had the certificates and all of that,
Right.
I haven't seen any proposals for that. And in fact, you're identifying one of the areas where GENI most needs input besides operations is in security. There is a security architecture, but we haven't really had a lot of people who are, you know, really trying hard to push beyond what's already out there and deployed for technologies for security.
So you essentially have a whole federation of people who have root access. And
Right.
so you just
Without-
kind of run with a,
without a clever idea for controlling them.
yeah, so you kind of have to run with the assumption that everybody is trusted, which doesn't-
obviously doesn't work. So no, it's more like we have to find the people who are going to come up with the clever idea and get them in and fund it.
suppose there's an impossibility proof.
Yeah, that would, well, that would be good to know so we don't waste the time.
Okay.
Yeah,
All right.
either way would be fantastic to
Thank
get
you.
more input. Thank you all very much, and please feel free to stop us. We'll be here for the duration of the conference.